The holidays are here, and what would the holidays be without some AP Chemistry? So your winter assignment from me is to learn the entire gas units, because the day you get back, you will have a test on gases. So what do I mean by gases? Yep, we're talking about those types of gases. But let's say, what actually defines a gas? What is that gas's state? Well, in order to know the state of a gas, you need to know how much of it there is. And in chemistry, we're particularly talking about how many moles. So if you're at STP, you have 22.4 moles for every 1 liter. So if this cloud was a liter of gas, I would have 22.4 moles. Or I could take the mass of the gas and divide by its molar mass. Or I could take its molarity and multiply it by its volume to figure out the number of moles of that particular gas. I also want to know about the temperature of that gas, specifically in kelvins, which, remember, is degrees Celsius plus 273. I'll also want to know how much volume that particular gas takes up, so I'd want that in liters. And lastly, I'd want to know the pressure of a gas. In particular, I'd want that in atmospheres. So I've got a couple different quantities here. I've got a couple different variables, all of which tell me something about the state of a particular gas, or tell me about the state of matter that is a gas. The number of moles is symbolized by the letter N. Temperature is represented by the letter T, obviously. Volume we represent with the letter V, and pressure with the variable P. What's that spell? Well, it probably doesn't spell much of anything. But if you've been in chemistry before, you're probably starting to think, wow, that looks a lot like that pervinert equation. Well, you'd be right. And we're going to talk about pervinert in much greater detail in future videos. But for right now, these are the quantities that define the state of matter that is a gas. For right now, let's focus in on pressure, because that's probably the new unit to you if you've never seen this before. That might be a little too much focusing in. There, that's a little bit better. Gases have no attraction between them and the other gases that make up a gas, between the gas and the other particles in a gas. And they're in constant motion. And because they're in constant motion, they are constantly colliding with the walls of their container. And they take up the space of their container. And they fill it completely, fill it uniformly, which means there's not a lot of gas in one space and then less in another. It's all pretty equal and even. Now, because gas particles are moving and they have a mass, they exhibit a force on the container as they strike it. And if you've taken physics, or if you've expressed any interest in physics, you know that force is mass divided by acceleration. So the units for mass would be the kilograms, would be the base unit, and the base unit for acceleration is meters per second squared. So we express this value in kilograms meters per second squared, which is a big bulky term. So instead, we honored Sir Isaac Newton and named this a Newton. And that's what's striking the walls of the container in this particular spot. There's a particular amount of newtons striking this one particular spot as this one gas molecule collides with the container. But there's not just one gas molecule colliding with the walls of its container. There's trillions and billions and more than we really care to count. So each one of them is striking the walls of the container, and since they're constantly moving and they're constantly colliding with the walls of the container, we measure all of that energy together, and that's what we feel as pressure. So pressure is simply a force per unit area. We've already said forces are measured in newtons, and area would be meter times meter, so meters squared. And this isn't actually a new concept. It's been around forever. And when I say forever, I mean like back in the 1600s. Back in 1643. Evangelista Torricelli, yes, he was Italian, invented an instrument that could measure atmospheric pressure. He called this the barometer. A barometer is a dish filled with liquid mercury with an inverted graduated cylinder in it. As atmospheric pressure increases, those gas particles, boom, 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 collide with the top of the liquid mercury, boom, 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 and push it up the inverted graduated cylinder. The amount that they rise is called a millimeter of mercury. Imagine that. And bada bing, bada boom, you've got your first unit of pressure, a millimeter of mercury. Years later, to celebrate and to honor Torricelli, we named 1 millimeter of mercury is the same as a torr. Now, most of the world's populace lives near some body of water, both for commerce as well as for fresh water, and because of that, we based a unit of pressure on what pressure is at sea level, and we've called that 1 atmosphere. And if you take a barometer and place it perfectly at sea level, where it will experience perfectly 1 atmosphere, you'll find that the mercury will rise up 760 millimeters. And since a torr is the same as a millimeter of mercury, you could also say it will rise, or the pressure you'll experience is 760 torr. Another scientist, a French scientist, who didn't have such a cool beard or mustache as Torricelli, came along, and the French like to change the names of things. And so he said, screw this crazy Torricelli guy. I'm going to change this. Whew, small peek behind the curtain there. I'm going to change this to pascals. That might not actually be how the story happened, but I didn't know how to transition as easily. So you just need to know that 1 atmosphere is equal to 760 millimeters of mercury, which equals 760 torr, which is equal to, you probably didn't guess it, 101.3 kilopascals. I told you wouldn't have guessed it. All of these units all define the exact same conditions, and that is called standard pressure. So anytime you see something that says at standard pressure, you're talking 1 atmosphere, or you're talking 760 millimeters of mercury, or you're talking 760 torr, or you're talking 101.3 kilopascals. Lots of names for one way of thinking. Another device that can be used to measure pressure is called a manometer. And this is particularly useful for measuring the pressure of a contained system, of a gas in a closed container. And it's kind of a tug of war, where atmospheric pressure can push against liquid mercury, and the pressure inside the container can push against liquid mercury, and whoever wins, you can tell the difference between the two to figure out the pressure in the closed container. If the pressure in the container is less than atmospheric pressure, that means atmospheric pressure is pushing on that mercury or with more force than the pressure in the container, and it will push that level of mercury down. The amount that it pushes it down, or the difference between the two, is subtracted from atmospheric pressure to give you the pressure in the closed container. If the pressure in the container is greater than atmospheric pressure, then that means that pressure in the container is going to win this push of war. Tug of war is a poor analogy. And it's going to push that liquid mercury further up the tube on the atmospheric pressure side. The difference between the two added to the atmospheric pressure tells you the pressure of the closed container. And it's through devices like this that many of the gas laws, particularly ones that deal with pressure, were derived and found out. So, hopefully, you now have a brief or cursory understanding of gases.